Recordings rolling. It's Thursday, January 8th. We're on lesson 2, solving exponential equations. I'll show you guys the 2 examples of that in a few minutes. This Alex has been open, of course, for a few days. The due date is went ahead and tag on to next Friday. Here, guys, I want to remind you guys too, your next Pi goal is 70%, and the due date I have for that is March 11th. Right? I think tomorrow will give you guys, tomorrow's a good Alex day. So tomorrow you can either work on this assignment or your general Pi goal, which of course, two separate things. Okay. Another event going on tomorrow is called Tied Together. So I'm going to show you guys the same email that I got. So we're all looking at the exact same information here. It says this Friday will be Tied Together event. VHS students will be released from each class by announcement after attendance is taken. We'll start with 9th grade and work our way to seniors during 4th period. Since 4th period is lunch, please have all seniors go to the gym for the first half of class on Friday, and then your class for attendance, and then go to B lunch. Please tell them about this so they know what to do Friday. To clarify, all seniors, here, I'll show this to you later. All seniors should go straight to the gym for Tied Together Friday during 4th, and then go to class for attendance. And then afterwards, all the seniors are going to be lunch. Okay? Any questions? Let me know. Okay? Okay, so that's tomorrow. You just listen for announcements and follow that. And if you're a senior, go straight to gym. All right, so that's that. All right, so what's with solving exponential equations? Okay, so now you guys remember exponential equation? Maybe you have the x variable in the exponent. That's what they said exponential. Okay. And if you what if you want to solve for x, but x is in the exponent? Here, let's do example 1 here. Looks pretty solid. 4 to the power of 5x plus 1 is equal to 64 to the power of 7. Maybe something like that. Okay. What if I want to solve for this x right here? Bam, what is x equal to? Okay. Now, normally what I would recommend whenever x is in the exponent you're solving for it is to use a process called logarithms. Now, we haven't quite gotten to that in your book yet. Did you guys do logarithms at all in Algebra 1? Logarithms? No? Okay, right. So that's an upcoming topic. I think it's like Module 8, right? But this particular lesson, your book has sort of an alternate way to go about it, which is to look at is there something common about these bases, like 4 and 64, and then work from there. So I'm just going to do this particular technique for this particular lesson. Okay. Now in the future, you can definitely use logarithms, which I probably default to anyway. Okay. But what is 64 compared to 4? Guys, is 64 4 raised to some power? What is 64 in terms of 4? Yeah, 4 to the power 3. Right? Because I know 4 times 4 is 16. Well, that's 4 squared. And 16 times 4 is 64. Okay, so 4 to the power 3. Yeah, of course, you could always use your calculator too, right? If you weren't sure. So let me show you. 4 to the power 3 is 64. Right? So what I'm going to do is substitute the 64. I'm going to put 4 to the power 3. Okay, so that will make it look like this. Okay? So I have on the left side 4 to the 5x plus 1, and we're still solving for x, is equal to, and then 4 cubed, all raised to the power of 7. Is that okay? Okay. Okay. Right. And then everything else is algebra rules that you guys have learned already. Right? Like guys, a power to a power. What do you do with this on the right side? Multiply. Yeah, multiply. So this is 4 to the power of 21. Okay. So on the left side, 4 to the 5x plus 1. And the right side is 4 to the power of 21. Is that? Yeah. How many guys see the next step?
There's the 1 over, right?
Well,
or subtract.
Guys, 4 to the power of this is equal to the 4 to the power of that. What do you know about this compared to that?
The x is 4, probably. I really hope.
Oh, okay. Yeah, true. Yeah. Right. Guys, I could say that these powers have to be equal to each other, right?
Oh, yeah.
Because 4 to the a equals 4 to the b. A must be equal to b, right? So 5x plus 1 equals 21. Is that true? Is that?
Yeah.
Okay. So then, all right, algebra rules, subtract 1 from both sides. 5x equals 20. Divide both sides by 5. X is equal to 4. Yeah, x is 4. Okay. Now, guys, could you take the answer and plug it back into the original statement, see if it makes a true statement?
Yeah.
Okay. Yeah, you could totally do that, and it would work. I think on the main video I made, which is about 45 minutes long or so, but do that too. Okay. Right. There's also okay. a method where you can solve with graphs. Right. So I can show you guys a Desmos example. Let's do Desmos here. Right. So you can find a graphical solution. Okay. So what if I said y equals how about 2 to the power of x as one graph, right? And what about as a different graph? Y is equal to 7, right? Just as a constant value. Right, let's go back a little bit. Right. You guys see where those two curves intersect? Right. So if I said 2 to the power of x is equal to 7, then what is x equal to? And it's a weird decimal. It's like 2.8 something something. You guys see that? But you can just be where the graphs intersect. You guys see that? Right, so you can solve things graphically. Right. All right. What else do they have in here? Yeah. Okay. So a lot of these examples are like exactly what we just did. Here, I'll do I'll do one of these word puzzles with you guys, but otherwise it's pretty much what I just showed you guys. And so let's do number 10, battery life right here. The battery life of a certain cell phone starts at 8 hours. Looking for where's okay. Right. The battery life decreases at an annual rate of 30%. Right? So if you buy a brand new battery, it'll charge and it'll last for 8 hours. Right? But every year after that, it lasts for, well, not quite as long. Right? So these batteries have some, this can follow an exponential decay curve, which I think I put that one away, but you guys remember I showed you guys an exponential decay curve a day or two ago. Okay, how many years will it take for the battery life to go down to only 2 hours, round to the nearest tenth if necessary? Okay, so I can set this up. No, this could follow. Do you guys remember I showed you guys interest rates the other day? This was like the amount you have as a function of time is equal to the principal times 1 plus the interest rate, like as a decimal, to the amount of time. You guys remember that? Right. This is basically the same format, but I can modify this a little bit. I can say the lifetime. Here, I'll do L for lifetime. Or is that what they called it? The battery, yeah, battery life. Okay. So battery life. Battery life. Okay. Oh, as a function of the number of years gone by equals the initial battery life times, and then 1 plus r to the t for t is in years. Okay. Now the catch with this one is this is actually exponential decay. Exponential decay. Okay. Like if I make a graph of this, I can show you what basic graph looks like. Okay, so be lifetime as a function of time. Okay, that's going to start here at 8 hours. So this could be in hours. Right, time passing by could be in years. Okay, so at time 0, you buy a brand new battery. It'll last for 8 hours before you have to recharge it. Okay, then every year after that, year 1, 2, 3. Okay, it's going to last not as long, not as long, not as long. Okay, and the overall shape of this curve is going to do like this. It's going to asymptotically approach 0. So maybe after like a century, the battery might only work for like a few seconds or something. Okay. All right. So let's plug some numbers into. Are you guys give that so far? That premise? Okay. Let's plug some numbers into this. Okay. So the lifetime as a function of years past equals. Okay. So we're going to start with 8 hours. Multiply by 1 plus. Okay. Now this R. Now yesterday maybe it represented interest rate, but here it represents the deteriorating life of the battery. See where it says it loses 30% every year? 30%. Okay. So what do you think goes in for this R if it's losing 30% every year?
30. Oh wait, no, I don't know.
Okay, guys, what 30%? What is that as a decimal? 0.30. Right. And also since it's losing, this plus should actually change to a what? Yeah, minus or negative. So it's actually negative 0.30, isn't it? Right. And then that's true year by year by year. So I can still put some variable number of years up here. Right. But hey, I can kind of rewrite this, clean this up. So the lifetime as a function of years past equals, we'll take the 8 hour start lifetime. Okay. Guys, this all comes out to 0.7, doesn't it? 0.7, 0.70. Okay. All right, so there's your general formula right there. Okay. So you can plug in any number of years that have passed and figure out how long the battery's going to last. Like, for example, after 1 year, be 8 times 0.7 to the 1, okay, which would be 5.6 hours. So I can say after 1 year of having this battery, the battery's going to last for about 5.6 hours before you have to recharge it. Okay. Okay. No, what they asked, they said let's take this all the way to 2 hours. You see 2 hours? Okay. So right here, I'm gonna put 2 hours. Of course, 8 hours times 0.70 to the t. So make that. Is that? Okay. Now here, the way to properly solve this really is with logarithms, which we haven't done yet. So the second best option, I think, is going to be to plug that into Desmos. Let's make a graph out of this. Right, kind of like the graph I just showed you guys right there. Here, I'm going to scoot this up so I can see that expression. Okay, right, and then for the lifetime curve, I'll do y equals, we're doing 8 multiplied by 0.70 to the power of the amount of time passed, right? And then, oh yeah, you guys see that red curve right there? Isn't that basically what I've shown you guys for exponential decay? Right, right. And then we're going to target a 2 hour lifespan, 2 hour lifespan, right? You guys see where these curves intersect? Right. See 3.89 years, 3.89 years. So there you go. That's the answer. After 3.89 years, the lifespan of the battery will be 2 hours before you have to recharge it. Okay. You see that? And that pretty much encapsulates the any type of example they could ask in that lesson. Yeah. All right. Okay. So there you go. If you want to watch the full video with lots and lots of examples, then I uploaded a long video. You can see lots and lots of examples. Right. If you want to work on this office assignment, you can do that, and I can walk around and help you guys. If you want to work on your general Pi goal, that's also okay. Right. And tomorrow will be an Alex day.